Today, we're going to be setting up a few things, but just to give you the right tools, you're using Gitpod. You'll see that in a second. And this is going to pull down the code from GitHub, and it's going to run everything for you. You don't have to bring your own laptop. In fact, I've done this presentation on a tablet via Gitpod. You can watch this on YouTube, on Twitch, and if you have questions, you can ask on YouTube Live, Twitch, as well as Discord. Some of my team members, DataStax team members, Cedric, and a few other folks are there as moderators to help you if you have specific questions.
Absolutely.
So did you want to add anything else, Cedric, before we move on?
No, I feel like, okay, so we do have the streams both on YouTube and Twitch, as usual. To do the exercise today, we can go Gitpod. Everything will be set up for you, the full Eclipse running. Keep asking questions on Discord, and as usual, all the materials are available on Discord, and you can download everything.
Excellent. Thank you. So first thing we'd like you to do is to go ahead and launch Gitpod. And all you need to do is go to the repo link, which is also on the YouTube Live, and I'll just show you very quickly what that should look like. And at the very top, after you get here, there's a button called Open in Gitpod. Just click on that. And I had run this earlier, but I have a workshop, a container that's already running. I'm going to go ahead and delete it, and I'm going to just start a fresh workshop. And this is just to show you that I'm starting fresh. I don't have anything here from before. I'm in the same exact place that you guys are going to start off on. Right? So this takes some time. It's building out our environment. Let it go. And pretty soon what you should see is a IDE that looks similar to Visual Studio Code, but it's not Visual Studio Code. It's made by the people that made Eclipse Thea, which is an open source Eclipse on the web. And it's actually Visual Studio Code extensions compatible. Anyways, those people have made this service called Gitpod. It's amazing. It's really good. We've been doing more and more development with it. I recommend it for your personal projects, maybe even for your work projects. Why are we building this app? Right? We're building this, this app with the event-driven toolkit. Why? Right? Is this just a toy project for us? No, it's not. We're actually building this application called Leaves to manage knowledge within our company. I know there's a lot of tools out there, but this is a way for us to not only build software and learn how to scale it, but also to experiment with new technologies, right? At work, we're not always able to, with our clients, not able to suggest the brand new technologies. On our projects, we can play with whatever we want. Our knowledge base is just a way to organize links and collections and share them with people. How do we use it? Well, beyond us sharing knowledge internally, we generate websites with this. So Cassandra.link is a website that we run. You can go to it. I would say it's the best online knowledge base outside of DataStax, but it's a third-party neutral site. We curate content. There's blog feeds. It's basically the new Planet Cassandra, and this is that makes it a very important part of our business to be able to publish this website on a daily basis and to scale this website. Now, this is just the tip of the iceberg. We have other knowledge-based sites that we're going to be publishing along the way. Right now, we're focused on Cassandra. We use a combination of open source technologies that run on PHP and MySQL, and then we have code that copies data to Cassandra, to Solr, yada, yada, yada. Right? It's a complicated infrastructure. It is all on containers, and it's pretty much all serverless, but we want to move away from MySQL. And we're going over to 100% Astra, 100% Cassandra. We're going to be moving away from RabbitMQ and Redis as a simple queue to Kafka. because we want to make this an example application that people can use and get their hands dirty with event-driven architectures. You're going to see this picture again because we're going to help you build out this whole application. And as you can see, we're using DataStax Astra to power APIs and as well as statically generated websites. Currently, we're focused on just Cassandra and just REST APIs today. Why do services, or why do APIs, or why do microservices on Cassandra? Cedric is actually going to go deeper into Cassandra fundamentals, but for why we love Cassandra for microservices and APIs, well, normally in the microservices architecture, which is very popular these days, normally everybody has a different database for each service. Whereas in Cassandra world, we can set up a new key space, a new data center, and essentially have isolated deployments in one infrastructure, in one cluster for the whole platform, and have a standardized platform. And because it's multi-model, even without DataStax Enterprise, it's got JSON support, it's got tabular data support. There's a lot there that we don't have to go to other databases, basically. That's why we like using Cassandra. I'm going to give you a quick overview of what is REST versus what is a microservice and what is event-driven architecture. They're related, but they're not all the same. In our transition, in the last 5 to 10 years, as we've seen clients transition and go through digital transformations, the technical architecture of their platforms has gone from monolith to microservices. And it was first called, services-oriented architecture, but still those, SOA platforms are pretty bulky and heavy. The main principles of going from monolith to microservices is that we make things composable. We make things smaller, more iteratable with smaller teams. In a monolithic application, you have everything spaghetti code on a couple of different databases. You may have 2 or 3 different layers. But eventually, as you start to go from monolith to everything distributed, what we end up having is more flexibility, more scale. You look at Google, they'll push out a little feature, a beta feature to a certain group of people to validate it. And if it works well, they push it out to everybody. That wouldn't be possible if they weren't using a microservices architecture. Of course, what goes with microservices architecture is a little bit more work. And the work is generally on how you design the system, how you design the messages, and how do you connect everything together, right? If it's one application, everything is just being passed through function calls. When you start to get distributed, then you have to make API calls. And so let's talk about REST API. So REST, I'm not going to read through the whole thing. You guys all know what REST is. But for our case, REST is just representational state transfer. It is used to move a state from one database to another database, right? Just at the end of the day, when you call a REST API, you're getting the state of that system at that point. And there are some verbs that are standardized. Built on top of REST are GraphQL, HeadEOS as different mechanisms. But for the most part, REST is just HTTP-based APIs. REST helps with microservices because you can create a microservice with REST and have another REST API use that microservice. Well, what is a microservice? A microservice is a microservices architectures are loosely coupled with other services. They're small. They could be REST, but they could also be MQP or Kafka. It's up to the designer, the architect of the system, to decide, do we want microservices with REST? Do we want microservices with Kafka or let's say RabbitMQ? Because in REST, we have synchronous communication. In queues, we have asynchronous communication. Generally, as I mentioned earlier, they have their own database, right? They have their own DevOps, and things are brought together using the saga pattern that things go from one microservice to another microservice to another microservice until things are done.
Yes, also,
this is great.
Yes, also, so today would be mostly REST, But now, as endpoint, we do have people doing as well GraphQL or gRPC, any new way to expose endpoints, but that's still HTTP. And now with HTTP, you can go sync, async, and reactive.
Absolutely, absolutely. And and this is really for the future, is that once we have REST and we have REST microservices, we may want to scale this. And the best way to scale systems is through asynchronous distributed platforms. And to make a REST API more scalable, essentially the best thing we can do is to introduce queues. Actually, adding event-driven or an event source not only makes the API more scalable, it actually makes it easier to integrate sagas into that whole flow of information. And so event-driven just means that everything that is happening in a system is broken down into either a command, and that's the event-driven part. But on the request side, it is coming directly from a data store. And so this architectural pattern, command query request segregation, is one of the most well-known patterns used in event-driven architecture and microservices architecture. And actually, Cassandra helps with that. Cassandra helps with that tremendously because it moves information and it can help us materialize certain types of information for us. I'm going to go ahead and pass it to Cedric now, who's going to walk us through some fundamentals of Cassandra. Here you go.
Yes, thank you very much. So let me take over here. All right, so back to the fundamentals of Cassandra. As usual, I will make it quick today because this is mostly you, Raoul, working. So let's move forward. Apache Cassandra is a distributed NoSQL database. Every word is very important. So it's distributed. You can install Cassandra on a single node. A single node can hold about 1 terabyte. You can do more. Cassandra won't block you to do more, but it will get slower. What we want to have is nice little node, 1 terabyte, and up to 3,000 transactions per second and per core. It's distributed, so we want you to have multiple nodes. Okay, all these nodes communicate to each other using a protocol called gossiping, and in there is no master. Nodes are grouped with something called a data center or a ring, as you can see here. And so what can you do with those rings? Okay. Okay, let me see something here. Let me see something here. Just want to check something. Okay, for some reason. Yeah, let me go back here. All right, that's better. All right, so this is the ring we want to build, okay? Multiple nodes, and each node have 1 terabyte of data. What do you want to do with that? Well, if you need more capacity, add new nodes. And if you need more throughputs, add new nodes, okay? So I don't look at the database from other colors. What I would like to understand is the more throughput, the more capacity you need, Cassandra makes sense because it's scaled linearly like that, okay? Data is distributed. That means even if a small data set like that, I would say 15 record, we will spot one of the columns and we will name that a partition key, and data will be distributed based on the value of the partition key, okay? Look at the column here in red. Data is distributed based on this value. And even with this very first slide, you can realize that doing a select star from a Cassandra table is not a good idea because you are doing a full scan of your cluster. This is not what you want, right? All right, and so you may immediately realize that you should have a where clause, and in the where clause, you provide the value for the red column, and it's called a partition key. Okay, so now let's say we do have our token range, which is part of the value evenly distributed around the cluster. Okay, we don't store the full value, you know, the red column, the full value. We store a hashed value of this one, which is called a token. So each node is in charge of a token range. Now I'm a client and I want to insert a data in there. At the client level, the data will be hashed, okay, providing a token 59. The token will be addressed to any, this data will be sent to any node. There is no master. The node becomes the coordinator for this request, and only for this request. It's not master slave, it's just coordinator for this request. It's not in charge of 59. It will simply send the data to the proper replica, like that. And now the proper replica have your data. So data is distributed, evenly distributed. Data are balanced among the nodes just for them to work with the same CPU. You don't want to have a single node to have all the data. Fine. But the data is also replicated. We define something called a replication factor. How many times does the data is replicated? If I put 3, my data is available in 3 nodes, replicated 3 times. And this is what I marked with the little colors here and there. All right. Now, if I need to add a value, then the coordinator node will push the data into the 3 nodes, like that. Nice. So, there is no master. Data is replicated. What does that mean? That means I can lose any of the node. It's not a big deal. What happened? Now the data will be sent to the 2 remaining nodes, and it will store locally with something called a hint. And when the node goes back online, I can put it back the data, and the system is self-healing and recover from this. Okay, so I show you some distribution, some little ring data center. In a Cassandra cluster, you can have multiple rings. So you can have some first deployments using geographic distribution, having one ring in multiple regions. You can read and write from everywhere, and Cassandra will do the replication for you. You don't have to worry. It's two-way synchronization. You don't have to copy data on your own. It's done for you. Also in Cassandra, there is something called a key space, which is kind of Oracle schema. And per key space, you define how the data is replicated. So you can have key spaces where data is only located in Europe, GDPR or regulation law. And you can have also key space distributed all across the world, all part of the same Cassandra cluster. And we show you little nodes here, but big web giant like Apple, Instagram, Uber, all using Cassandra for those reasons, and they do have hundreds and thousands of nodes. So Apple, for instance, has communicated that Apple, we have 175,000 nodes available. Not part of the same cluster, but that's still 12 petabytes available online. And if the network is not great in between the data center, not a big deal. Cassandra will replicate when the bandwidth is there. What you can do with geographic distribution, you can also do it with hybrid and multi-cloud. What about having one data center in each cloud provider and also one on-premise? You do have the same data layer available everywhere. With everything I told you, you can remind the CAP theorem available in distributed system, telling that in a distributed system, you cannot ensure consistency, availability, and network partition tolerance at the same times. Network partition tolerance means if I lose the network between the nodes, what will happen? Well, if you do have a master-slave architectures, if you lost the network, part of the network won't have the master, and then we elect a new master, and when the network goes back online, now in your cluster you do have 2 masters, And so this is what we call a split brain problem, and we need to figure it out, which is a proper master now. So in Cassandra, there is no master. And remember, the data is replicated. You can lose any of the nodes. So availability is the thing, and also partition tolerance. By default, Cassandra is AP. Don't worry, be AP. Now, by configuration, query per query, you can set, oh, I want my query to be less available and more consistent. And it's done with something called a consistency level. And it's done per request. Okay, I won't go into all the detail about consistency level today. Today it's packed of hands-on, but you can get that. You can also ensure consistency with Cassandra if you provide the proper consistency level. And we love that. Architectures and capabilities. This is a slide as an architect you want to know. What are the proper use cases for Cassandra? First, you want to use the scalability capability. You can scale as much as you want. So this is used for high throughput as volume, heavy read, heavy writes, and use case, event streamings, Internet of Things, analytics, anything related to time series. If you have already heard about Cassandra, this is probably in those use cases, time series, event streaming, high volume. Why? Because not only Cassandra is very fast to write data, but because it scales as much as you need. Second range of use case is about the availability. I told you data is replicated, and this is small nodes, kind of commodity hardware, right? You can lose any of the node, and as such, the system is still there, still available, no data loss, and always on. And if you are really in hostile environment, you can even increase the replication factor. Like you can lose multiple nodes, and it's still okay. I mean, for the no data loss always on, all use cases are correct. I put you some caching, market data, pricing, inventory. What about having the market data in a Cassandra cluster? In the morning, you dump all the market data of the day. It will replicate all across the world. And now everybody needs market data. We'll simply read a node close to him, reducing latencies, and have the same things everywhere. And you don't have to copy. Cassandra do it for you. And by the way, there is also TTL on the value. So you can say, this data is for today. Okay. Distributed. Okay, I told you, you remember geographic distribution, technical distribution. Okay, GDPR compliant. I can have a key space located to one node or one location. And okay, everything related, all the global company would need that. Okay, I told you about Uber, Instagram, Apple. It's mostly because it's all distributed and global companies. And it's cloud native. AP, commodity hardware, anything modern cloud application would like to use that capability. Cassandra can be deployed in Kubernetes with some operators now. And so it's very open to any use case for hybrid cloud, multi-cloud. All right, so Cassandra is nice, okay, can do a lot of stuff in the cloud. What about providing you today Cassandra as a service in the cloud? You don't have to install anything for the hands-on, and for that we will use Astra. Astra is Cassandra as a service provided by DataStax. And in there is a free tier. So you can create your instance for free. It will stay there. You don't have to provide any paywall, any credit card. So Astra is, as I told you, Cassandra in the cloud ready for you, and also extra services like DataStax Studio with notebooks to do exercise, to do Cassandra query language, queries, start working on your data model right in Astra, and don't have to install any tools. And because it's as a service, you don't have any operation to maintain. It's all secured, and it's of course simplify the app development, and this is what is today for. Okay, so with Astra you can use CQL, there is tools, and you can use all the drivers. So as you can see, multiple drivers, and today we will use the drivers, the Python drivers and the NodeJS drivers to connect to Astra to insert data and retrieve data and implement a full REST API on top of Astra. So why use Astra? Well, as you can see, nothing to install, ready to go. You can create your key space. You don't have anything to operate after that, and there is a free tier, and of course it can scale if you need to. All right, and now let's go all together and launch your Astra instance. So in the show notes of the video, I provide you a step-by-step tutorials to set up your Astra instance. If you already have your Astra instance, you simply can reuse it and go to hands-on mode with Raoul. And during the time you are starting your launch Astra, I will hand over back to Raoul.
Great. Thank you, Cedric. Appreciate that. Before I go into launch Astra, whenever I interview people for their Cassandra knowledge for our team or for our clients, I see if they can explain Cassandra to me in 30 minutes. You just did that in about 10 minutes.
Yeah, but that's my job.
No. I tell people Cassandra is really not that complicated. You can pretty much explain it, in 10 to 15 minutes. Yeah. Yes. So as Cedric mentioned, Astra makes the development process a lot easier. And what it does for us is really just focus. It allows us to focus on iterating the product, iterating the service, and not the infrastructure of the data. We love Cassandra. We know how to use it. We have scripts for data stacks for Cassandra, for Terraform and Ansible and Docker, and nowadays Kubernetes is out there. That's great for a lot of companies that have the team members to do this properly. But if you're starting out something or you want to prototype something, even in a large company, this is way better. It's way faster to get started. When we start Astra, the first thing that I'm going to actually log off and show you. If you go to astra.datastacks.com, essentially you'll see the screen like this to either sign in or register. I have been a Astra user from before they added the social sign-on with Google and GitHub. So I have an old school email account. And when we sign in, really all you have to do is hit new database. I already have a free account set up here, so I'm not going to make another one. And you'll just choose the free tier. This will be selected for you, and give it a database name, whatever you want. In our case, the database is called Anant. Actually, I'll show you. I think it's called Anant. No, it's called Platform, and then the key space is called Knowledge, right? The username, it's arbitrary, right? You can call it whatever you want. The password, it's important that you have a good password, but it doesn't have to be super complicated. In fact, my password, I'll just give it to you. It's 123456. Why am I so cavalier with it? Well, as you'll see, when we have a database on Astra, the only way to connect to it is via a secure certificate bundle in a zip file. And that's what we're going to use to actually connect to Astra. Without that certificate, you cannot connect to this cluster. End of story, right? So that's why it's okay. Just pick a good password, but it doesn't have to be 16 characters with alphanumeric and caps and numbers. It takes some time for this cluster to start. Sometimes I've gotten a cluster in about a couple of minutes, sometimes taken about 10 minutes, but essentially you should see one database on one cluster. And when you click on View Database, or when you click on Actions, you see a couple of different menu items. When you click on View Database, yes, sure. Is that better, guys?
Yeah, a bit bigger, that's better. Thank you.
All right. Yeah, so you should see the main View Database screen has the connection details. It actually has some REST APIs already generated. There's a GraphQL API already generated. And that's very useful because it just gives you direct access to the data. The type of APIs we're creating, we're being selective in terms of what we're giving back to the API endpoint user. There's also something called Developer Studio, where we'll verify a few things. There's a CQL console where we can log in. Right. So it takes some time. Just let this go, and just as the systems are getting created for you, I'll go back to this picture that I showed you earlier. So you know a little bit about REST, microservices, event-driven architecture. Cedric has given you a really solid basic understanding of Cassandra, and the goal is for us to leverage Cassandra. As data comes in, we're going to continue just relying on Cassandra to scale linearly, right? More data comes in, we can scale it. More requests come in for data, we can scale it. And we don't have to worry about it because of the way it distributes the load automatically. We can have any of those nodes as a coordinator. Any of those nodes can be down, and other nodes will take that traffic, right? So we don't have to have any load balancer for Cassandra. It is already going to scale. As long as we have a good data model, it's going to scale, right? And the APIs that we're going to create today are really focused on an individual item. We're not really materializing any, we're not doing a query table, for example, today. We're just focused on a object table where if I have the ID for the object, we're going to be able to retrieve it. You just went through this setup earlier, and if you have, if it does take you a little bit longer, everything that I'm showing you is on the README for this repository, screenshot by screenshot. There's also a blog post. There's a video from before, and then after this session is over, this video will replace that video. So rest assured that if you're taking a little bit longer, you can come back and everything will be here. Some resources for you. These are the same resources that our team used to create this application. In fact, the people that were contributing to this project in our team are fairly new to Cassandra. They're developers that just started using Cassandra recently, and so they were learning how to do Cassandra with Express and how to do Cassandra with Flask. So what you see is an end result of new people learning how to do this, and we learned all this stuff online. So if you go to Cassandra.link, you'll see a bunch of curated links. You can search things, as well as Cassandra.tools. But if you have any questions, feel free to reach out to us later or on the chat today. Some of our team members that helped build this are on the Discord and Twitch chat. Just ask a question and they'll help you out.
Now, I need to jump in. Come on, this Cassandra.link is very something. You should go there. This is now the go-to. We used to have planetcassandra.org. It's not there anymore. That's really Cassandra.link. You do have RSS to be updated, and also awesome Cassandra. You got all the tools out there, all the best blog posts. That's really a resource you should leverage on. And at DataStax, when we do have something to share, we communicate. We send that to Raoult to put that on the website as well. Raoult and his team is actually administrating all these platforms and doing all the stuff to have this ready for you. Thank you for that.
Thanks for the shout out, Cedric. Yes, it's definitely a passion project, and it brings us a lot of joy in making this. It really we love the technology, but we love telling people about it too. All right. So the hands-on portion of the workshop, as you had seen earlier, you're going to end up with two APIs, one in Python, one in Node. You're going to have, actually, in addition to that, there are some tests in Node to validate that the APIs are working, both the Python and the REST APIs in Node. We're doing everything, except for Postman, we're doing everything in the browser with Gitpod, with DataStax's Developer Studio. And in fact, Postman, there are some web-based tools as well, but Postman happens to be the most common tool that people know about, checking out APIs. There's a template on the repository, which you can download and import into Postman, and so that you'll have all that populated. Just a quick tutorial, or sorry, a quick tour of the Gitpod IDE. As I mentioned earlier, it looks like Visual Studio. When you open a repository in Gitpod, if it's an open source repository, which ours is, it will be free for you. And you can use it for up to 50 hours. And there's no limitation. In the terminal, when you run things like a Node program or a Python program, if it exposes a port, like port 8080 or port 8000 or port 80 itself, it will run the service and it'll say, do you want to expose this port? And immediately you will have a URL that you can use from the whole internet, right? So this makes development a lot easier. Our team started out the development of this API in Docker, and then we were able to start doing the rest of it on Gitpod. In fact, Gitpod is using our Docker file, a custom Docker file, to get this up and running. So yeah, the code base on Cassandra.api is organized in 4 main folders, right? There's a folder for the importer. There's a folder for the credentials where we'll download and we'll add our credentials. There is a folder for the API. And there's also a Node API and a Python API there. The UI is coming. Don't worry about this, but there's also UI that talks to these APIs to see and edit this information. But today we're just focusing on the API. To follow along, you have already set up the database, hopefully. The first thing that we're going to do is download the credentials and save those to our workshop. And the way we're going to do that is by going to our Astra cluster. This is our dashboard. And I can either hit connection details here, and it brings up this modal dialog like this, or in the screenshots, you can click on the cluster and the connection details are here. What we're going to do is we're going to download this secure connect bundle.
Yes, so you may want to refresh the page before downloading the bundle because the link is available for 5 minutes. Just a trick.
Thank you, Cedric. I appreciate that. And I have a folder here. I'm just saving it. I've had it from before, but I'm going to go ahead and save it. And once I have it on my desktop in my folder, the way to get it to my Gitpod repository is, fairly straightforward. Let me make sure I can. Looks like if I leave my Gitpod for a second, sometimes it goes on pause, but because it's already been pulled out earlier, it takes about 5 seconds for it to come back up. One nice thing about Gitpod is that if I want to put files into my workspace, I can just drag my file in there, right? So here's my zip file that I downloaded. I can just drag it into Astra.credentials. It's uploaded. It's right here. You can also right-click on this and just upload. Let's see, upload files, right? Just treat it like you would any other desktop application. And I'm going to increase my screen size. Hopefully this is good. There we go. Okay. When you're starting off in Gitpod, you have a Linux shell inside that anything you could do on Mac OS X or Linux, you can do here, right? We're able to edit any of the files in here. So the first thing that we're going to edit in the Astra credentials is the username, password, cluster name, etc. Right? In the instructions, we say try not to use hyphens or underscores. You can actually use both. It's just that the way we're doing the tutorial and relying on a very simple workflow, there's some stuff that we have to fix before you can do that. So don't worry about that right now. So username, my username here is just not admin. My password, I told you earlier, is very simple. I like this password. It's almost as good as QWERTY. Cluster, we have platform. That's the name of our cluster. Our key space is as what we called it, knowledge. And right now, I don't have any tables in my cluster. I can just go verify that by going to CQL console. Let me see if I can. I don't think I can zoom into this much. And I'm using standard CQL commands here in the CQL console. So we see there's a knowledge key space. I can use knowledge semicolon and let's see what tables we have. So it's empty. There's no tables.
Raul, yeah. I do have a couple of questions on the chat now. So one is, which framework do you use to create the microservice? So not only the language, but also maybe the framework names. And second question would be, is it part of a Lambda architectures?
Gotcha. That's a really good question. The first question, we're using, for now, as just a reference example, Python, specifically Flask on Python. We thought about using Django, but Django is a little bit heavier. We just wanted to focus on the REST API. And then on Node, it's basically JavaScript. You can also use TypeScript, but it's NodeJS with the Express framework as the middle layer. Now, could we use Lambda architecture? So Lambda architecture is different from AWS Lambda. Lambda architecture is about having a stream of information coming in, being processed, as well as all that data being saved. But then the batch process is able to reconcile all of the stream data. That's Lambda architecture. Can this be used with Lambda architecture? Absolutely. But we haven't gotten to the stream processing yet, right? I think what you may be asking is, can we use AWS Lambda with this? Absolutely. You can create JavaScript functions in AWS Lambda that use basically JavaScript, the Cassandra driver for JavaScript, and do the same thing. The workflow will be different in that you're just going to focus on what the request is and what the response is. And then AWS Lambda takes care of the routing and the endpoint for the API, deploying all of the functions. We do have that as a future goal after we do the whole workshop to come back and say, can we make everything serverless, including the processing code and the API code, but not today. Hopefully that answers your question.
I think you did. I would just add something. So to my knowledge, in the Lambda architecture, there are 3 layers. speed layers, batch layers, and restitution layers. So speed layers is indeed about ingesting events in real time, and Kafka/Cassandra fit this use case, and this is what we are discussing about. And on the restitution layer, it's most of the time also synchronous call to get back the data once it has been reconciliated by the batch layer. So in a sense, it can be used in 2 layers of the Lambda architectures.
Absolutely. Absolutely. Thank you for that clarification. Yeah. And it actually gives us a lot of flexibility. When using Cassandra, you can have multiple data centers where you have a speed layer on one coming in, and you can have another data center where you're constantly reconciling at the same time, right?
Yeah.
So absolutely. All right. So going back to this, just taking a look at my database. I don't have any databases. Another thing I want to do is log in to the Developer Studio. And I can go to the Developer Studio by going to Platform and clicking on Developer Studio. And Developer Studio is a trimmed down version of DSC Studio. It's a notebook-style web interface that essentially allows us to interactively query and visualize some information. So I'm going to delete this old notebook, and I'm going to make a new one so you can see how we're doing this. I'm just going to call this knowledge. I have an existing connection from before. If for the first time you're logging in, it's going to ask you for credentials, just the username and password, and it will set up a connection profile for you. Once I'm connected, I can select CQL in this particular key space, knowledge, and I don't have any tables in here, but what I can do is see my schema over here, right? I've got my key space, knowledge, I've got my table. I don't have any tables in there right now. Okay. All right. So after we have our credentials saved, okay, next thing we're going to do is we're going to import data into our cluster. And that importer is actually going to create our schema in there as well. So the importer is in this astra.import directory. The table that it's creating, let's take a quick look at it, quick peek at this. Yep,
Make it
sure,
bigger.
sure. How about that? Is that better? So our table is, probably roughly 20 columns, and there's some collections in here, some timestamps, some Boolean, but essentially it's a mirror of the API that we already have running on MySQL. Okay, and earlier what we were doing is we were indexing that data into Solr, and then the Solr was also providing some of that API. Well, the code REST to Astra initially was using that REST API, downloading it, and one by one importing it into Cassandra. What we did in order to not to bring down our cluster, our search stack Solr cluster, we just downloaded about 1,000 records, just the standard API call, and saved it. Now, this code, if you were to replace this with get data from a URL, REST API, it would work exactly the same. Okay, and in our case, we're gonna send in 1,000 documents, 1,000 rows, 1,000 partitions, and this is a fairly simple importer. It just goes through, does some validation of each of the fields. We're doing basic data engineering, saying if there's no value here for the preview picture, let's use a dummy image, for example. And to run this script, we need to have some prerequisites. Right? So the prerequisites for us, if you click on the data migrator, are the Cassandra driver and the request driver. So we're going to copy this command here. And I'm just going to paste it. And looks like it's installed. Then the other command I'm going to run is pip3 install requests. Okay, and that's done. So to run my importer, I'm going to type in Python 3. That's the version of Python we're using, although we could probably just type Python. Astra.import rest to Astra.
Cool.
Let's see, it gave us an issue. Oh, I did not finish what I was doing earlier. I needed to give a URL. So I'm just going to, I need to give it a name for this table. I'm going to call this URLs. And I'm going to go back and make sure that when I refresh this, I don't have any old tables in here. Yeah, good. All right. Sorry about that. Let's go ahead and run the importer again. It connected. It verified that we're running essentially Cassandra 4.0 inside Astra. And it just iterated over in bunches of 100 records and inserted them into Cassandra. The code to insert into Cassandra, it seems very familiar to those that are familiar with SQL, but this is not SQL. And the other really useful thing that's happening here is we were able to insert into our table direct JSON, right? We downloaded JSON from a REST API, saved it to disk in our case, but we could just as well have taken it from an API and verified it and then send it directly into Cassandra. And to verify that we have this data inside Astra, if we go back to DataStax Studio, we'll see that the URLs table got created, all of these columns got created, and I'm going to do a select. I'm not going to get, well, you know what? Fine. I'll just do select star from URLs.
Yeah, this is a DataStax Studio. Nice.
And there's right now, let's see, 9 pages of results with about 10 rows each. It's about 100 rows in here. If we look at the data, some of it is in tabular form. Others are in this form right here, which is a collection. And we've verified that our data is in Cassandra. And if you're skeptical about this DSC Studio and you like the CQL console, which I can't seem to zoom in, so just bear with me. I'm just proving to you that in the CQL, if I use the same key space, which is called knowledge, not key spaces, and I do select star from URLs, there's a lot of data in there. So I'm going to just do Control-C and say limit 1. And that's one partition, one row that is stored in here. Right? So we're done with the import process. And I'm going to go back and move on to the next. So now that we have data in there, let's talk a little bit about the Node API, right? What does it look like before we go ahead and start it? So the Node API is just like any other Node API that you would write with Express, except that we're using the Cassandra driver, and we're passing it a secure connect bundle in our credentials. The rest of the work in Node, it should not be that much different from Mongo or MySQL or Postgres. It should be almost exactly the same. And when we look at the layers of the code where we're retrieving information or we're deleting information, it looks just like SQL. So in this case, earlier we had a key space called killer video, and we're using leaves as a table name. We can say, get me everything from the table. And since Node.js is JavaScript, it was able to take that result set and directly send it back via API. Right? You will see in the Python example, actually, we use the JSON keyword to get data from Cassandra as JSON and send it out. Let's run the the Node API real quick. In order to run the Node API, we're going to have to change the directory to go into astra.api. And if you look in here, there are 3 directories. Leaves.api.node. And all Node applications, we have to run a tool called npm install. So I'm going to go ahead and run npm install and let it do its thing. What it's doing is it's downloading all the dependencies for this application. If you remember, I mentioned that this Git pod is based on a Docker file. Actually, we could add all of these dependencies well ahead of time, but this is not a production application. This is a development application, and we want everybody that's learning how to make APIs to follow the steps. And okay, this is how I make an API in Node with Cassandra, or this is how I make an API with Python in Cassandra. So you would have to do this on your development environment anyways. Okay, npm is installed, and in our npm our Node documentation, the next thing we're going to do is we're going to run the actual API. So in here, we're just going to say npm run dev. All right, it brought up a service. It says a service is now available on port 8000. We're going to go ahead and make that public. And we're going to hit open browser. And it's going to open up a new tab. Now, you're seeing this and you're like saying, it's not working. It actually is working. We just don't have a handler for that root endpoint. If we take let's see, this right here, /API leaves, and append it, then we get a lot of data back, right? And I don't have a pretty JSON viewer, but what I do have is Postman. And what we're going to do is download the Postman templates, which are available here. It's a JSON file. Just save it. Save as, I'm just saving it in my directory here. Okay. And sometimes when you click on a Postman collection link, it'll just open Postman. For some reason, it didn't do that right now for me. And then what I'm going to do is open up Postman. I don't think it matters which version of Postman you're using, but don't worry about setting it up if you don't have it right now. You can do your testing of the API all inside the browser.
Nice.
So I'm going to import and have a folder. Sorry, file. And I'm just dragging the file that I saved up here. Collection, go ahead and import it. And there we go. You'll see that I added several tests and a couple of different templates. I'm going to go to this one. You'll notice that it has port 8000 and it has localhost. Well, we have a API endpoint now that does not have a port, right? So you're going to copy either from the browser window, or you can always come back to this Git pod, click on the ports icon here, right? Sorry, the ports button here, and get the URL by just clicking on open browser. So I'm just copying this URL. And mind you, this API is exposed, so we have not put authentication and authorization on this REST API. That's going to be on you. So if you take this code and just put it out there, you have to do some work to secure the code.
Yeah, but that's better for hands-on. I mean, that's okay. And I love how you simply import the Postman templates, and you do have the full test suite ready. I love that.
Yeah. So I'm going to do a quick test of this, and as we can see, it works, right? It was able to get a bunch of data, and you'll notice that the structure of this information is it's a content application, right? We're dealing with URLs and we're dealing with HTML content, so it may look a little ugly, but that's okay. Don't worry about the JSON output so much as each of the API endpoints are working. So this one is giving me everything that it can, but I can also do a specific request for one of the IDs. So let's say 14013. I'm going to copy this one ID, and then I can. Well, let me first do this. I'm going to copy this URL again and paste it here. Oops, wrong copy. And then this is going to be 14013. And we get back only one result, right? So we know that this is working as expected. And if you look at the Astra UI code later on in your time, you can connect this API endpoint to that and be able to browse this information in a GUI tool, right? Now, let's try something. Let's delete something on the REST API and see if it actually deleted it in Cassandra. So to do a positive test, we're going to first verify that this 14013 is it actually coming from the DataStax Astra. So on my Dev Studio, I'm going to add another little CQL command here. Select star from URLs where ID equal to 14013. Oops, I think it's a text. So we do have this data, right? Another neat thing is if I say view results as JSON, I can see that data, right, as it exists inside Cassandra with TTLs, everything that I would be able to see here. I can also just get this data back as JSON.
Yeah, this feature is not known enough, especially from web developer. You can read and write from Cassandra as a JSON format, pretty neat. But there is a schema. You can do whatever you like, but you can read and write as JSON, pretty neat.
Yep, exactly. And we are using that feature in the Python, actually. It's insert as JSON and retrieve as JSON. So we know this is here. Let's delete it. So I copy this. And by the way, if you pay for Postman, it has these features like environments and variables where you can just say, here's my URL environment variable, and then here's my, this other variable, and it basically populates this stuff for you. But since we want you to be able to do this without paying anything, that's why we're doing it the way we're doing it right now. All right, so the delete is just the same endpoint as the get, right? But it's just the verb is different. The HTTP verb is different. That's the only thing that's different. And it tells us, hey, I deleted it. You didn't like this website, I went ahead and deleted it for you. Okay, so we deleted it. Let's verify. And we're going to run the same CQL command. And we don't have the data anymore. So our Node API seems to be working okay. Just a quick preview of the Python code before we go to the Python code. But again, pause for a second, wait for people to catch up a little bit.
Maybe I feel that people struggling a bit. Yeah, we can slow down a bit. We do have time.
Yeah, and if you have any questions, feel free to ask.
Yeah, I will read and ask to Raoul on spot.
The other thing that we're not going to cover today, and people will often ask, is when you make a Cassandra table, we have to design the primary key in a way that if you don't have the partition key, you cannot get that data unless you do allow filtering. Although this is not a tutorial on data modeling, there are ways after you add data to create indices to retrieve that data without having the primary key. And in Astra, we have 3 types that we can use. One is, well, there are really 4. There's the native indexing, right? Your primary key, your partition key, that's an indexing engine built with a partitioner. We have secondary indices. And secondary indices are good for data that are low cardinality. So in our case, we have a column, let's say websites. Well, right now it's low cardinality. It may grow out to be more. Or is published, right? That's a low cardinality. We wouldn't want to do that unless we knew the primary key or some other criteria, but that's available. The other is materialized views. Materialized views would be great for things that have high cardinality. So actually the domain name or the source URL would be potentially a good one. The source domain, excuse me. And the other one, which recently people have seen as experimental, which is SASE, storage attached, SS table attached, secondary index. It has some really neat search features. It has like partial wildcard type features. So it's that, and that's something that we're going to actually start using in this API because even though we have a Solr index and this is not replacing it, it will be useful to see how fast it is. Let's say if we're going to filter by tag or filter by domain, how quickly can we get that information? Right. The Python code actually isn't that much different. It's very similar. The Flask Python framework is very succinct and brief if you want it to be, just like Express. We're doing the same thing. We're connecting to Cassandra. We're taking a particular route like at slash or slash API slash leaves, and we're responding to it with a response. The difference in the Python version, to show you, is that we're not just doing a select star from our table. We're doing a select JSON star. Right? When we're doing Node.js, we're in JavaScript world. So whatever data the driver gives back to us is already JavaScript. We can just turn that around and send it over. But if we're using Python, we're getting the data as basically a tabular result set from the driver. But if we say we want it as JSON, we'll get it as JSON. And then we can manipulate it as JSON inside Python before we send it out. The delete statement is going to look exactly the same, right? It's not going to change.
No, delete is delete. Delete as JSON. Yeah, we are not Mongo.
So Python, let's go into our terminal here. We can actually keep this running and open up another terminal to run Python, but because the Python API also runs on the same port, we're going to have to shut it down, right? So I'm just going to go back to my terminal window and do Control-C. We're going to leave our Node.js directory. And I just want to be in my workspace home directory, which is Cassandra.api. All right. The Python documentation says that, okay, we need to have Cassandra driver. Well, we installed that earlier. We need to have requests. Well, so we installed that earlier as well. So the only thing we need to install is Flask. You can either install using the pip command, or I'm just going to type in, the pip with the -r command where you give it a file, or we can do it just, pip3 install Flask. So to show you what the pip requirements file looks like, it's just this. Well, actually, we do a couple of other things, but that's for another time. Here we go. Pip3 install -r. And it's installing a couple other things that we're using for processing down the line, but the important prerequisites right now we're worried about are just these three. Right? So the only thing we needed in Python to get it up and running, and this is why I like Python so much. It's not like I don't like Node, but look at this. The whole code base for Python is this one Python file and this requirements file. That's it. We go to Node, and we're dealing with the package.json, which is like requirements. Then we have an app, a config, a processor, and a server. I mean, you could go on and on and on.
No shame, no shame.
I like Python because it's quick and dirty.
I like Java, and I probably also download a ton of stuff.
Yeah, well, that's a different. Java can solve different challenges, which I think Python is meant for different things as well. But for getting stuff up and running, Python is really really amazing.
I agree, but Node taking over the world. So yeah.
Oh yeah. Oh yeah. Oh yeah. So in our app, just to show you the code that is responsible for connecting, right? It's on line 70. It connects, it verifies the version, it tells us if something happened there. And as you saw in the preview, it's just when we say /API/leaves, it's just getting this from Cassandra and getting it as JSON. And we append as JSON and send it back out. When we get a specific amount of rows, right? Same thing, but we say limit, let's say 5, okay? And the way we do that is just by adding an ampersand rows equal to, let's say 10. And we're going to try that out when we run this. Okay. So Python, again, the code is not too much different. When we run it, all we are doing is saying Python 3 app.py, and Gitpod will run it. And what happened is the code connected to Cassandra, verified that we have connected to a Cassandra 4.0 cluster. It's Astra, but it's under the hood, at least the versioning system says it's 4.0. And it's here, it's on this port. Because we had earlier already exposed the port 8000 and didn't ask us again, we can always make this port private if we want. And all that does is that it creates access between our computer and that REST API via a session. That's all it's doing when we say make private. When you make public, everybody can see it. Now, we get a not found. That's okay. Remember earlier we had to put in /API/leaves, and we get the data back. Cool. And let's see, we'll say /leaves and rows equal to 3. And it is a lot smaller. If I say rows equal to 1. Yeah. So this is working from the browser. Let's do a Postman test. Your URL shouldn't change because the server that Gitpod created for you, that host name isn't changing. The endpoint isn't changing, right? So we're just going to hit send, and we get the data back.
Yeah, so Gitpod is very new, but it's very, very powerful. So not only you do have Python and Node ready to go, the full Eclipse Thea, but yeah, also you can expose port, execute stuff. I'm impressed.
Yeah, this part of Gitpod, where you just said, okay, it has Python, it has Node. You can even develop C++ games with visual, like OpenGL, and watch it in Gitpod.
Cool.
Like that's how advanced it is. So it is any type of development. I think it's great for that. So going back to what we were doing earlier, we did not change anything in our Postman test, right? And we were able to see that this is working. And our assumption is that every single one of these endpoints will behave exactly the same as in Node and as in Python. And what you should see from this is it doesn't matter who the developer is on your team. If they're good at Node, or if the team is good at Node, use Node. If you're using Cassandra, you can be rest assured that at least the Cassandra part is going to be scalable. You just have to make sure your Node code is okay as well. If you have people that have Python, you can have people that use Python to get data in. You can use Python Flask to get data out from an API perspective. So it doesn't really matter, right? In the world of microservices, it doesn't really matter what you program in as long as it's succinctly contained. And in our case, we've done 2 equivalent microservices. Why would we do that? Well, we may find that Python has better machine learning libraries readily available to evaluate some models that were created, right? We can use Flask to talk to Python, to talk to scikit-learn or TensorFlow, and be able to take a created model and respond. Whereas on NodeJS, we would not necessarily be able to do any machine learning, right? So you can use these as starting points. We verified that the leaves API is working. Let's see if we go back and look for that same 14103, if it's there. It's not there because that resource has been deleted, right? Of course, it's not there. If let me see what is there though. So 14012 is there, and I will ask for that. Oops. And that is a single result that we have. We have some other endpoints, which is to get the tags. And so in this case, this particular link is tagged as sales and marketing or sales. If I want, I can also delete these tags. This will not work, I don't think. Yep, okay. So that's because we need the unique ID for this one. And I can get that.
Correct. Too much text.
Too much text. Yeah, this is a big article that was saved. Let me go back here. I'll go look at it in my DataStax Studio really quickly.
But hopefully it's not a voucher, it's a text, as long as you need.
Yep. So I deleted my tags. Now this shows that this no longer has any tags set, right? Back to Postman. So Postman is a useful tool for us to verify if an API is running. But actually, what we can do is also do a unit test around our APIs. Okay, and we have some unit tests written in JavaScript, and we can take a look at those as well. So in the Leaves API tests, the app spec, I'm going to just go to a little bit bigger. There we go. Our specs basically are to verify if I insert data in SQL, can I retrieve it, right, using the endpoint? And do I get it as expected? And I mentioned earlier that it doesn't really matter which API is running, it should run the same. In this case, we create a set of rows, and we retrieve it, and then we want to see is everything available in that particular partition. We insert it, we delete it. We want to make sure that it's not there. Unit testing is a big part of creating microservices. That's because when you release a microservice, when you release the REST API, you want to make sure that everything in that service works 100% as designed, right? If you say to somebody else in a big team where there's, let's say, 10 other microservices teams, if somebody makes a change in your code, in your team, and it gets shipped and it's not working as expected, then it really could screw up operations for all of those other APIs that are relying on it, right? So being test-driven is super important when creating microservices, if for the only fact that no matter what you do, whether you change your code from Node to Python or you decide to use a different database, let's say you're using DataStax Astra one day and you decide to use DSC Enterprise the next day on premise, you still have to make sure that all of your code is working, right? And the best way to test code is to have a unit test that creates random data. Oh, not really random data. It creates data and checks to make sure that it's working properly. There isn't other complex business logic in this microservice, and there really shouldn't be. But if there was, we could verify that too.
Yeah, so we speak the same language. I did one workshop about Java last week, links on YouTube as well. And same, I started with the test, TDD, and each time I change the thing, I run the unit test suite just to see if I'm okay, of course.
Absolutely, absolutely. So to run the tests, we're going to have to go into the test directory, and looking at this, we also have to run npm install because this is a node based test, and we're going to say run test. Okay, so the only thing that we may have to change is to change the API in which we're testing from. Right, so we have our API running, and I'm going to go into. I'm going to quit my. Actually, you know what? I'm going to open the new terminal. I'm going to leave my API running. I'm going to open a new terminal, and then go into leaves.api/leaves.test. Okay, I'm going to run npm install. It's going to install a few more things. Okay, and then in our app spec, we want to change from localhost to the endpoint that we have from Gitpod. So make sure it's still running, right? We didn't change anything. And we're going to go back to Gitpod and paste. And we're going to run npm run install. Oh, sorry, we already ran install. Tests. Okay, what did it say? Oh, there is no such thing. npm run test.
Yeah.
So what it is,
I cannot criticize Node.js anymore. Sorry.
Let's see.
I was caught by the chat.
Okay, so looks like it's hanging for a second. I'm gonna come back and I'm gonna run it again. Okay. Right, so something's got. Let me come back here and let's see what's happening. We got our endpoint. I'm going to verify something real quick. So we did, as part of the test, truncate some data in here because the testing process has to be starting from the same, right? We need to make sure that everything in the test is as we inserted it, not necessarily as we want from an existing. That's a different type of test, by the way. So go here and run star. I love that about DSU Studio. It tells you if your CQL is wrong. Okay.
Yeah, it does.
So we emptied the data. Go back and let's see.
Yeah, and in the meantime, so if you like the content, please subscribe to the YouTube channel. It helps us, give us a thumb up. It will also help us to be retrieved in the search. We are here every week, same date, same hour, but we have an announcements to make at the end of today.
Okay. And what I'm doing, by the way, is just to ensure that we're starting with the right URL. I just ended my Python API and I just restarted it again. And let's see. I know what I was doing wrong. I was putting a slash at the end of my URL, and that was causing a redirect because it was the wrong path.
I did the same.
But as long as I don't put the slash, it worked okay. So we were able to create a record via CQL, retrieve it, done. Create a set of rows in one partition, retrieve it, done. Insert via CQL, delete, verify, gone, done. Insert via post, make sure it was added. Insert via patch, or update via patch, which is a REST verb. Get the tags for a particular item, insert tags, verify, and delete tags and verify, right? So our tests worked on Python. Now let's make sure they work on Node, the Node API. Right? Even though the tests are in Node, right now the Python version of the Node of the API is running. So I'm going to quit this for a second. I'm going to quit my Python, my Node, my Python endpoint. I'm going to go back into npm. Excuse me, the Node version. I've already run npm install. So I'm just going to say npm run dev. So it's running. It was already exposed. Astra is connected. I'll just do a quick sanity check. There's nothing in here. That's expected. That's because we have not imported any data. We have truncated it because of the last test. And when we run the test again, the expectation is that it should work exactly as the Python. And as the French say, voila. Is that the
yes,
right
this is what we did. Et voila.
Et voila. Okay. So what is it? It's doing something different. Okay, so two things fail. Which you know what? It's okay. The point is
it's not
that,
a bug, it's a feature.
We have to see what's different, right? Why did it fail? So it kind of makes things exciting. But I'm not going to debug it right now. The code that you have here, as I demonstrated, is the same code that you have access to. All you have to do is get on to the GitHub if you haven't already, open it up via Gitpod, go to Astra, make a connection, make a database, get the connection, and every single thing that I've done, you should be able to do. So, I think the value of Astra, just to kind of bring it back, is really in not worrying about Cassandra. And the value of Gitpod for us is not really worrying about a dev environment. So you can just focus on creating your application. With that, I presented to you today what we came out to do. And to verify that, I'm going to open my agenda. Do we have cloud accounts in Astra? Yes. Did we understand some best practices and ANA patterns for Cassandra? Through the code, you should, because we didn't get to do the data modeling aspect of it. Do you understand the basics of CQL and CRUD? Yes, now you know that you can do, select, insert, update, delete, just like in SQL, except you can also do with JSON. You can do inserts and updates, and you can do select this from JSON. And we have a simple API in both Python and Node that connect to a Cassandra cluster and work. And with that, open it up to any questions, any comments.